Hello everyone, I'm Soresh Mitra from Sri Venkateshwara College of Engineering. I'm a third year student pursuing BE in Computer Science and Engineering. Today I'll be giving a presentation on unicast routing techniques for mobile ad hoc networks. Abstract and mobile ad HOC network MANET is an autonomous system of functionally equivalent mobile nodes which must be able to communicate while moving without any kind of wired infrastructure. At this end, mobile nodes must be cooperate to provide the routing service. Routing in mobile environments is challenging due to the constraints existing on the resources, transmission bands, CPU, time, and battery power, and the required ability for the protocol to effectively track topological changes. This paper discusses the issues of routing in mobile ad HOC network by focusing on the main solutions proposed in the literature to cope with the mobility. The papers surveyed the techniques adopted for the case of unicast routing, that is, when it is required to send a packet from a source node to a destination node, by illustrating how they are introduced in the main representation protocols. Introduction. The term MANET, Mobile Ad Hack HOC network, refers to the set of wireless mobile nodes that can communicate and move at the same time. No fixed infrastructures are required to allow such communications. Rather, all nodes cooperate in the same task, routing packets to destination node. This is required since each node of the network is available to communicate only with the nodes located within the transmission radius R, while source and node S and a destination node D of the MANET can be located at a distance much higher than R. When S wants to send a packet to the D, the packets have to cross many intermediate nodes. For the reason MANET belongs to the class of the top multi-HOP wireless networks. Proactive protocols. The advantages of these protocols is that a path to the destination is immediately available so that there's no delay experienced when an application needs to send a packet. In some of the case, this can be useful for interactive applications. The main mechanism adopted in proactive protocols are following: to increase the amount of topology information stored in each node, to avoid loops and speed up protocol convergence, to dynamically the size of route update or the frequency to optimize flooding, to combine DV and LS features. Tailoring distance vector protocols DSDV. The distance vector protocol is one of the first attempt to customize the classical DBF protocol. The key elements of DSDV are an aging mechanism based on the monotonically increasing sequence numbers that indicates the freshness of the root and which is used to avoid root looping and count to various infinity problems. Second is the use of root updates sent periodically every update interval or increment routes update sent to on a topological changes. The delay of route updates for the route are likely to be unstable, that is those for which a new update is on the way towards the node. Reactive protocols. A different approach for routing in mobile environments is routing on demand. The approach is characterized by elimination of conventional routing tables at the node and consequently the need of their updates to track changes in the network topology. On demand routing protocols calculate a path before data transmission. If a data is not generated by nodes, then the routing activity is totally absent. For such reasons, they are also called reactive protocols. A reactive protocol is characterized by following procedures used to manage this path discovery, path maintenance, path deletion. Data forwarding is accomplished according to main two techniques, that is source routing and hop by hop. Position aided protocols LAR. The novelty in location aided routing protocols is estimation of the position of destination node used to increase the efficiency of discovery procedure 41,42. Only subset of a node are queried during the discovery phase, specifically the one so-called request zone nearby the estimate. LAR uses standard flood as last resort when no estimations are available. The position can be obtained, for example, from the Global Positioning System (GPS). The request zone is calculated from the expected zone, which is defined as the zone where the destination node D should be located from the viewpoint of a source node S at the current time T1. Given that the S is its known position at some time T naught in the past and its average velocity. Protocol performance analysis. Protocol performance analysis aims to measure two complementary aspects. The first one is efficient routing service is providing with respect a given set of cost of indexes, that example bandwidth, battery energy consumption, CPU cycles. The second aspect concerns application-oriented metrics, that the performance seen externally by an application in using protocols. To evaluate these two aspects, protocol complexity analysis and protocol simulation have been used. The aim of complexity analysis is to measure at a simplified and an abstract setting the resources required the protocol in the performing in a single protocol operation, for example, the reaction to the lineage breaking. Conclusions. Many protocols have been proposed in the literature to provide routing in the mobile environment. In this paper, we have illustrated the main techniques proposed to deal with the mobility in the case of a unicast flat routing. The experience gained in this wired networks have influenced the design of mobiles and HOC routing protocols in many ways. However, wireless mobile networks introduce several concerns that make routing issues completely different from the one providing to the fixed counterpart. For example, the limitation on a battery lifetime and transmission bandwidth, as well the notion of route stability leads to a new notion of the best route. Also, fairness is an important property of a protocol since all using always the same route results in the battery drain out for same mobiles. Thank you for watching this video. Please do like, share, and subscribe. See you next time.